To be fully honest, nowadays I don't write as much Go code as I wanted to. One reason is that at my current company, we don't use Go, we mostly use TypeScript, about which I still have mixed feelings, but to be fair, it works well for our team nevertheless. So I won't blame TypeScript much in this video. I still support few open source Go projects, so I still write some amount of Go code using the coding agents or manually, but oh boy, I miss writing more of it. Especially I miss the developer experience. I think nothing comes even close to what we have in Go. And interestingly enough, I think that becomes very important in the AI era. And so in this video, I'd like to rant a little bit about that, about the ergonomics of Go programming language, and maybe about a few other things. So things are changing. For better or worse, I'm not sure, but you can already see some trends forming. For example, Rust and TypeScript becoming the dominant choice for AI-generated code, while with the other languages, let's say you hear a little bit less about them. So the real question is, what programming languages will still matter in, let's say, 5 years from now? I personally think we will see fewer dynamic backend languages like Ruby on Rails, PHP, and Python for some backend workloads. Obviously, not because these languages are bad, they're really great languages for humans. But you see, before AI, languages competed a lot for human ergonomics. Now this competition is less important. And for example, the languages should be machine-friendly and performant, and that's the competition that matters at the moment. Take Ruby on Rails, for example. It's a very beautiful language, incredibly human-friendly language, but I would argue not the most machine-friendly one. Performance-wise or type system-wise, you see humans are really good at navigating this implicit context of languages like Ruby on Rails, understanding different DLCs and implicit magic, while models struggle a little bit more about that. And explicit systems are usually just simply easier to reason about. And then there are new so-called AI native languages. I stumbled across a few languages like that in the last few weeks, so let me just open and we can quickly go through them with you. The first one you probably heard about is called ZeroLang from Vercel. Honestly, reading this homepage about this language, I don't understand what's the spiel here. It says graph language, graph first programming language, source, small. Obviously, there is some syntax, right? I wouldn't say it's necessarily bad, just some syntax, but yeah, I wouldn't use that, honestly. Then another language I saw is called Veralang. Interestingly enough, let me zoom in. It routes humans to scroll and agents to read this QMD, which like what is it so different? Can't agents read this web page? But anyway, both of these languages feel like honestly AI slop, and someone just generated them with prompt like, "Hey, make me a programming language. Don't make any mistakes." You see, the models today are mostly trained on existing languages and ecosystems. The ecosystems are usually quite big, so you can find the good code and bad code and kind of split it into different buckets, right? Performant code, maybe not performant code. With kind of new languages like Vera and ZeroLang, I'm not sure if we'll be able to identify what's good and what's bad because there is no learning corpus. That's in my opinion. And then what about security or compilation? These languages are simply not battle tested and feels like a black box, honestly, to me. And that's where Go becomes really interesting, because in my opinion, and I'm sure that a lot of people will disagree with me, Go is really good language for LLMs, not only for humans, but for the models too. And I'm really rooting for Go to win this competition, if that's possible. So let's review a few things that I think make Go a uniquely good language for the agentic era. And let's start, for example, with the standard library, which is a massive library and incredibly well designed. You can build a lot of production systems just by using the standard library, which already has HTTP servers. You can work with cryptography, JSON parsing, with testing and concurrency, all of that in that library. And another important thing is that Go team takes the stability and security of the standard library very seriously. You rarely see the ecosystem level security disasters or vulnerabilities in the standard library. And then another great thing about Go is quick compilation. And that actually matters more than you may realize, especially in the AI coding. You see, humans can tolerate slower feedback, right? You maybe, run the compilation maybe once in every half an hour, maybe it takes a few seconds, but agents may compile your program hundreds of times while working on the task, so quick feedback loop is very important here. Okay, the list of good things about Go is actually huge, but just to mention a few things, it's a single static binary distribution. I think it's really nice to distribute your Go programs. It's a single binary. Close comes to that the cross compilation of your Go program. So from my machine, I can compile the program to different architectures. There are a lot of built-in things like Go FMT, Go vet, etc. There is kind of no dependency hell in Go. And yeah, Go is very boring to write and very explicit. You can say that Go is pragmatic. There is usually one way to do things in Go. And I think that's Go's greatest strength. Go intentionally removed many ways of writing creative code. So there is usually kind of less opportunities to make a mess with Go code. And usually the AI generated Go code looks surprisingly clean and maintainable. And now we're coming to my favorite indirect feature, which is Go's compatibility promise. Back in Go version 1, which was released, I believe, in year 2012, the Go team introduced the guarantee that basically says that old Go programs must continue working on a new Go versions. This sounds quite boring until you compare it to some JavaScript ecosystems where dependencies from 2 years ago start breaking. In Go, pretty much I can open any program that I wrote, let's say 10 years ago, and still compile it and run it. So that level of stability is extremely rare, and it's very important in the AI era. I think this stability becomes the new engineering value or very important property, because the last thing you want is to have millions lines of generated code to depend on some fragile ecosystems, right? Let's actually try this out. I found some Go project that I have on my GitHub from 9, 10 years ago. It has to do something with Google Speech and games, but the most important part is that it's written in Go. So let's clone it and see if it still works. So let's clone this project. Let's cd and then Go build. So now let's see if we have a binary. I think by default it's called main, so maybe just run main. Like that. Cool. And some server is up. I'm not sure, or I don't exactly remember what it was doing, but at least you see the compilation works, dependencies work, there is nothing broken after 9 or 10 years, right? Which is cool. I also think that formatting matters a lot, maybe more than people realize, especially while humans still reviewing the code, and I think they should. And so Go FMT adds an enormous value here. As you've seen, probably pretty much every Go program looks roughly the same. That's because the formatter is built into the language. And that's very useful to the agents too, because now you don't need to tell your agent what formatter to use or to format the code yourself after the agent generates a lot of code. Then there is great tooling like Go linting, Go vet, and so that lives in this very nice tool chain of Go language. I already mentioned the cross compilation, but I just want to show it again to people who might not be aware of that, because it still feels magical to me that you can do things like specify the operating system. Let's do Windows, so I'm on Mac, but then maybe to any architecture. Let's do AMD64, and then Go build. Now, if we explore our file system, we will see a nice executable or Windows executable file. And you can change these values to anything you want, maybe to Linux, and then architecture, maybe let's do ARM64, for example. Cool, and we have completed another executable for another operating system for another architecture. Pretty cool, right? And now our favorite topic, error handling in Go. I know that many people dislike Go's error handling because maybe too verbose, but it's very explicit. And again, as we probably already learned today, agents like explicitness. So let's put it on the screen so everyone knows what we're talking about. Pretty much every Go file has some error handling. And so let's look at this block. Errors are values in Go, and they should be treated as values. So the functions that may fail, they would return an error, and we have to handle that. That removes all the magic, and it's very explicit, right? Because also in Go, values or variables cannot be unused. So if we put an error here, it must be handled somehow. At least we should log it or return it to a caller. And so to me, I think you're almost forced to think about failure cases. So it's very hard to kind of miss the error in Go because you forgot maybe to put some code block into a try catch. And then there is a concurrency, which I believe is a selling point of Go. A lot of people come to Go because of how easy it is to create concurrent or parallel software, much easier than in other languages where you have to manage the threads manually. So we can see in the code base, you can probably already seen. So let's just go. Yeah, kind of that's a concurrent call, right? So just add Go to the function. Again, very easy for Agents to write concurrent code probably do less mistakes with that. One slightly controversial opinion I have is that AI will make boring languages more valuable, not less, because maintainability scales better than cleverness. Generated code does not need to be genius level engineering. It has to be refactorable, maintainable, and easy to verify. And I think Go is proudly boring in the right ways. I don't know whether Go will become the dominant AI era language, maybe it won't, but I think it will age interestingly well. Go still feels refreshingly simple, and I believe that simplicity will become one of the greatest features in the AI era. Thanks for sticking with me. Bye.